yeah, I think the recording is running. So please, Mohamed, we're very, yeah, we can't wait to hear you.
Okay, thank you so much, Maurice, for introducing me. So this lecture, I will speak about our 12 years or more work about do photogrammetric model to document the ancient forest lighthouse in Alexandria, Egypt. So we started this project, I think, in 2012. And I will not demonstrate all the go to the next lecture. I will demonstrate at the beginning how we started this project and what we achieved in the last 11 years to now to document the whole site. And after that, I will speak about another technique we follow to document the all individual blocks of ancient or remains of ancient forest lighthouse to complete some of parts of the lighthouse itself, which called the technique virtual anastomosis. And the third part, I will speak about how I use a technology called reflection transformation imaging and how we combine it with photogrammetry by a fully automated code to make some invisible inscription, which we never know there are exist under the water. And it came back to be visible from our eye, which was a revolution technology we used. And I will end the presentation speak about our old publication we did since 2016 till now. And also I will speak about some part about virtual reality and how we can use the site for a virtual tool. So first of all, I will speak about location of forest. So the forest island is located, of course, in Alexandria. It's under the water right now, sink it. And now it's located in front of Fort of Qaitbey in this area exactly. The site distributed around 15,000 square meter or 15,000 hectare. And the depth of the site is between 2 meters in front of the Fort of Qaitbey, and the deepest part is 9 meters, which is not too deep at all. But the problem on the site itself, the visibility is not in a perfect shape in most of the time of the year, because the site itself located on the well of the whole town. So the maximum visibility in most of the condition, like between maybe 2 meters, 3 meters, and in good condition, maybe 5-6 meters. But 5-6 meters is not the whole time in the year. So in 2012, we got funded from Owner Frost Foundation to use photogrammetry to document the whole site. And it was a big challenge for all of us, since, like I said before, the visibility wasn't in a good shape, and the technology in 2012 was unknown for many people. So we start to figure it out how we're gonna do that. So I will show you a map on the left about the location of the site, and here is the town of Alexandria, and the photo in your left is the GIS map recorded by the Centre d'études Alexandrie, the CEAlex in Alexandria in the 19s, using the total station data. And in the 19s, they spent like around 10 years and they recording around 3,500 block under the water. And this is what they did in the 10 years, so for the recording. And in 2012, like I said, we start to do the photogrammetry. So in 2012, like it was the time we built our methodology to take the photograph, since the visibility and vision and the waves, a lot of stuff in this area was a big challenge for us. And the photographer for the site, his name is Dr. Mohamed Abdelaziz from the Center Department, Underwater Department in Alexandria. And we use a very basic and manual tools as a guide for us to document the site, since the site is extremely big. And so we start to build some grid and do some experiment, take photograph and do process and see how it goes. So the data acquisition on the site is exactly simulates the drone image. Of course, most of the maritime and the diver know about how to take photograph under the water. And as you can see, the visibility is not in a big shape. So we have to be very close to the site. And the site, like I mentioned, is around 15,000 square meter under the water, which very challenge for us. So we decide to divide the site each season or each year, like piece by piece, by putting grid and start to capture the photograph. And as you can see here, Dr. Mohamed Said is so close to the object. It's variety between 1.5 meters and 2 meters sometimes to the object, which means that we expect we will got thousands of images at the end of this project. So this is how we make the data acquisition. And after that, after Dr. Mohamed Said takes the photograph under the water, I do the data processing or post-processing for the site. And as you can see from the top image, this is the type of image color I got, because the visibility and the condition is not in a big best condition under the water. So someday I got the photo in a green, light green, dark green, yellowish blue, dark blue, and this was a bit challenge for most of us, because as you know, photogrammetry is used like an algorithm detecting feature point, and this kind of algorithm, it's better to got like a homogeneous color to detect, to make it easy for the photogrammetry to see the software can recognize a photo, but sometimes it's got difficult. So that's why we, when we take the photograph, we made sure that we used a camera. We didn't use a videogrammetry. We didn't use a fish eye, since we are do this project for a research purpose. And we capture the whole photo in raw file format, which make us, for us after that, to make a post process for all the photo. And this is the result of a couple of examples in the down photo, how after I remove the filter from the image itself. Of course, this is a few images, this is like only 5 images, but I speak about thousands of images, like literally every day, Dr. Mohamed Said like capture more than 2,000 images per day. So, so this is an example for our first experiment in 2014 for around 1,000 square meter. The image in your left is before I do the post-processing, and as you can see, the color is mixed together, and some of feature what we wasn't able to see it, especially this project. The main project for the main purpose for this project is to create a full ortho-recified image to the whole site, and do study and do 2D drawing, GIS map, and see all the feature and the stuff. So that's why post-processing was so crucial to our work. So the photo in your left, in your right, is before post-processing, and the photo in your left is the same area, but after I do post-processing and remove the filter. As you can see, it's a big difference. This 1,000 square meter, literally in the site itself, we cannot see this area as a one piece if I'm diving on the site. This block in the middle is one of the door lintel of ancient forest lighthouse, and this door lintel is actually 5 meter length. And in the site itself, if I dive and see it, I will barely see part of this block. So, and this is how came very important to use photogrammetry to create an ortho-recified image, because in reality, we will never, and impossible to see all of this area in one piece. And as you can see, this is only 1,000 square meter. So this is how we divide our work. So in each season, we speak, like we make like a meeting, and we speak about which area we will cover in each season. And this is exactly how it's go our work. So like, for example, in 2014, we captured 17,200 images to capture this area. And in 2015, we captured this area and also this area. Just put this away here. And to capture those two areas in 2016 and in 2015, and so on, so on, so on. So for each year, we have each of the site as individual pieces. So here's the challenge. So we came about a big serious issue about how we will merge all of each season together as a one 3D model, and also as a one ortho-recified image, fully high resolution one. And first of all, for each season we capture, we take an overlap area between one season and another. Like for example, in 2014, when we capture the area and finish it, and we go in 2015 and 16, we made sure that there are an big overlapping area between one season and another. And we keep going on that. So this is one thing. And the second thing is when the diver go to capture some photos, some of the days actually the condition wasn't in the best way, and the photos not in a good condition, as a sharp, or visibility wasn't in a perfect way. So I ask, like I said before, I do processing day by day, just very it's an initial process, not the final one. And I back to the diver and I told him this area didn't cover well. Can you go to recapture it? And we do the same every day by day. So he recaptured and I do other processing and replace the camera and so on. So this is how we got a fully high resolution orthorhombified image. So again, back to the point about how we merging all the season together. So as I mentioned, we made sure for each season we take an overlapping area, and also we use a total station and georeference point to merge the whole site together. Like for each area we cover for each season, before we take the photograph, we distribute a ground control point for to get the coordinate for the site itself. Like for example, in 2014, we built like around 20 points or more, distribute all around the site. And after I make the 3D model, we put the georeference data and it's already automatically georeferenced. In 2016, 15, 17, and so on, we did the same procedure. Before we take the photograph, we put the ground control point and we do the georeference. So since the whole site will be in the same coordinate system, it will be automatically the orthorhombified image, and the 3D model automatically will be merged together. So, and the reason we take an overlapping area is to make sure that the georeference is in the lowest error as much as possible, because like I mentioned, the French mission, when they made the GIS data in the 19s, we got a big error in the X and Y and Z location, and it's more than like between 50 centimeter to 1 meter and above. But the final error for the location of the site itself is less than 10 centimeter, which totally big different. So the photo in your right is about how the divers from the French mission put the ground control point under the water, and how we take the locations, the X and Y and Z location. And of course, the total station is outside the underwater site. It's near the port of Qaitbey. So, sorry, I'll just put it down here. And this is actually the final result we achieved from 2013 till now, till 2000. We still work on underwater side right now, but this result from 2013 till 2020. And this is the whole area we covered till now. And as you can see here in the top image, the number of image we captured on the whole 10 years ago, and it's around 103,200 and other number images, which quite a huge amount of images we capture to capture around 80% from the whole site, from the whole 15,000 square meter under the water. As you can see, here is the fort of Qaitbey. And this is the whole area we covered till now by taking 103,000 images. The ground sampling distance, which mean the pixel for the whole site, is between 0.5 centimeter and 1 centimeter for each pixel. That means that I can make zoom in till infinity and see the grain of sand for the whole site, with something very special for all of us. We still will cover this. We didn't cover this mid area of the site itself, because this is the most challenging part, which cover with a lot of sand. There are not too many features on it. So I think in the future, we're going to start to focus to cover this area. So this is how it looks like, the orthorhombified image we achieved. And in the second image, this is how the camera location looks like, how the diver takes the photos. All of these black dots is how the diver takes the photos under the water itself. And this map is called digital elevation model. This one is so important for us as a researcher and archaeologist to determine and know exactly where is the lowest area and the highest area for the island, the forest island itself, and how the blocks are distributed, and how it's when the ancient forest lighthouse collapsed, how it looks like, and we can define where is the island and where is the block from this map. Another thing we did, we used the also specified image for, we make a comparison between the GIS map drawn in the 19s and the georeference also specified image we did to make comparison between the location and the error and this kind of stuff. So also we are in the future, or we are already did that. Dr. Isabel Harris, the director of the underwater site, she already drew the whole site from the beginning. Like you can see also 2D drawing, we can remap the whole site based on the also specified image. For the people who don't know what is also specified image, it's undistorted 2D image. And we can take a dimension, the X and Y dimension from it, and the dimension is 100% accurate. Same as I'm doing in the real site. So I can take the X and Y dimension from this map without dive anymore in the site. So I can redraw the whole site. And as I told you before, the ground sampling distance or the resolution of the site of the whole image itself is like between half pixel, half centimeter and 1 centimeter per pixel. So we have quite a lot of resolution to use. Another thing is extremely important about the site, and we notice that the sand level. So like, for example, in the top image, top left image on above, we can see the blocks here, which captured in 2014. And after 2 years in 2016, we capture the same area as an overlapping image. And when we merge both areas together, we notice that some of the blocks are disappeared. But we make some sort of deviation analysis. Since the two models are in the same coordinate system, we find that the sand level getting high in 2 years, like around 60 centimeters. This information was very interesting for all the archaeologists, which means that there are still a lot of blocks of ancient forest lighthouse maybe under the sand area. Like I said before, we after we make the whole also specified image to more than 80% for the whole site, Isabel Harry start to redraw the site again to really relocate some of the blocks which already located in the 19s by the French mission. And she noticed that there are more than like 4,100 blocks didn't record yet. So in the 19s, the French mission recorded 3,500 blocks. And from the photogrammetric also specified image generated in the past 10 years, we record 4,100 more blocks, which very, very interesting result. So another possibility to publish the site, we have of course the 3D model, and we have full control to distribute the 3D model to the community through virtual reality or through video. So I'll just put the music a little off. And in 2015, we create and publish online on YouTube in the CEAlex channel a 5-minute video for the whole site, underwater site in a 3D. So what you are seeing in this video is not the real site, but actually this is a photogrammetric 3D model created. And the great thing about using technology, like I mentioned, the underwater site, the visibility is so difficult, but in a 3D, I have a full control to create my own environment under the water. And this is exactly what we did. We make a simulation to the underwater site, and at the same time, we make it visible to the community. And this is the result, as you can see right now. Again, this video is created in 2015. And as you can see here, this is a diver size. And this is show you how the site is extremely, extremely big. This is a diver 1 meter 80 centimeter. So as you can see, the site is extremely huge. The 5-minute video took for me like 30 days, every day, 24 hours to create this video. And luckily, by the development of the technology, like I say, always say, the technology is never stopped, so it's keep development. So I create the same video with more visual effect and more realism, and it just created in 1 minute. As you can see, the technology go extremely fast. This video actually is the same. I use the same 3D model created, but more visual effect, more realism to simulate the underwater site. And this video created only in 1 minute. The previous version video created 5 years or 7 years ago, it took for me like 30 days to do it. And this one took only 1 minute. So this is a big difference.
Sorry, Mohammed, just as we're waiting, can I ask
Yes.
which software did you use for rendering this video?
Yes, it's Unreal Engine. It's a game engine software.
I say, oh, it's gorgeous, absolutely.
Thank you. Thank you. So yes, this is about the underwater site. The second part I will speak about is about virtual anastomosis, how we reconstruct some statues discovered under the water. And I will start with Isis statue. Isis statue is discovered by Kamal Abu Saadat in the 16th, and he informs the Egyptian Navy there are a statue in the underwater site, of course, in Alexandria, and the Navy actually lifted the 2 pieces of the statue in the 16th, and the statue, the upper part and the lower part of the Isis statue, as you can see, the statue tall length is extremely high, like it's more than 8 meters high, and it's broken in 2 pieces, and it's lifted from under the water and put it on the Maritime Museum in Alexandria. And the French mission, the Centre d'Alexandrie, by under the director Dr. Jean-Yves Van Breer, he lifted the crown from under the water in the 19th. Now we have the crown in Roman theater, like the crown moved in a different place in Roman theater in Alexandria, and we have the other 2 pieces of the statue is located in the Maritime Museum, also in Alexandria. And it was impossible for all of us to, it was difficult, not impossible, to collect the 3 pieces together. Also to make sure that the crown and the 2 pieces are belong to the same statue, or even, of course, the upper and lower part are belong to the same statue, but we are not sure how the gap between the upper and the lower part is, if there are a gap, if there are not, and so on. So we decide to make a photogrammetry for the 3 pieces together. As you can see, this is how Mr. Ashraf from the Center of Alexandria, so he represents actually a scale for the 2 pieces of the statue. And we also make a photogrammetric model for the crown individually. So without any interact with the object itself, we make a 3D model for each piece individually. And after that, we try by use computer graphic to collect the 3 pieces together. And we made sure actually the 3 pieces are belong to the same statue, as you can see here from these images. And all done in computer graphic. The scaled model, it's already scaled, 100% scaled, and it's like playing puzzle, but through computer, just you lift a 20-ton statue, you don't have to touch it on the real side, but you can do it in your computer, and once you make sure 100% it's belongs to the same statue, you can proceed and do it on the reality. So of course we can, by make a photogrammetric model, we can take dimension, and since the statue is already scaled, so the dimension is very accurate. We can measure the volume to know exactly the weight of the statue itself. And this information allow us, of course, to decide what kind of equipment we might got to lift the statue. Another thing we can, very interesting, we can do with the 3D model is about details. So the statue is a statue made from a very dense granite, red granite stone, and the granite is so densely material, and already the statue eroded because it's been like hundreds of years under the water. So the great thing about using 3D model, special like high resolution 3D model, photogrammetric high resolution model, we able to remove the texture itself and have like a totally shaded model, and we can add some filter like exactly we do in Photoshop, but in the 3D model to make enhancement on the shape of the 3D model itself. And as you can see here, we start to see a lot of details. It's very difficult to see it in the real side or even notice. As you can see here in this area, and the thin dress of the ice statue, the necklace of the statues, all details, decoration for the statue. And this is very, very important information we can do. And as I mentioned, we can take all of this information through our computer. We don't have every time to go to Maritime Museum or Roman Theater and just do the study and wait for a specific time on the sun to see some details and so on. All of this information, I can get it on my computer. I don't have to go anywhere. This is a very small video. I just demonstrate about how we make the anastomosis to the 3 pieces. And the guy represents the height of the statue itself. So this is a very quick video, and I would like also to mention that the statue is already now lifted from the Maritime Museum and the Roman Theater, and now it's brought up in one piece and put it in the Greek Roman Museum, which newly reopened a few weeks ago or a month ago, I guess. And now the statue is located in Alexandria in the Greek Roman Museum again. So another quick example, I will go fast about this example, and also Sphinx example, which in a 3 pieces. Also, these 3 statues lifted by French mission in the 19th from underwater side. And in 2014, we follow the same procedure. We make a photogrammetric model to the 3 pieces before the restoration team do a physical restoration to the 3 pieces, and we made sure the 3 pieces are belong to the same statue only by use computer graphic, as you can see here, before and after. And after that, the restoration team go to the site and do the physical restoration to the Sphinx statue. So this is about the virtual anastomosis. So here is the main topic of the lecture is about reflection technology called reflection transformation imaging, which I will explain what is it, and photogrammetry, which already mentioned on previous slides. And so I will go very basic about reflection transformation imaging. Unlike photogrammetry, if you would like to create a 3D model, you have to move the camera, and for each photograph, you have to get a decent amount of overlap to create a 3D model. But reflection transformation imaging, I don't have to move the camera, but the camera have to be in a very static position, like you can see here in your left image. The camera is in a fixed position. There are 2 ceramic balls, and the only thing is moved is a flashlight. So I take like around 70 image. Each image has a different light direction. And after I got this 70 image, which each image has a different light direction, I put it in another software called RTI Builder. And the software make a composition for all of these 70 image and create a one image. This image contain 70 light direction. It's exactly like I am in the restoration lab and I have a coin. And if I would like to read what inside the coin, I got like a lamp and I move the lamp all the direction. So this is exactly the concept of the RTI. So RTI is two methods. The first one is doing, it's called normal RTI, which I'm doing on the site. I got a professional camera, I got a flashlight, I got a ceramic bowl to capture the highlight for each flashlight I took. And the second one is doing virtually through the computer graphic, which was totally new. How this idea came to ours to do it in underwater. First of all, RTI, the main idea of RTI is to be able to see something we cannot see by move the light in different direction. And unfortunately, we cannot do that under the water because we cannot keep the camera in a fixed position under the water. And if the camera moved 1 inch or even less, I will redo the whole process from all over again. So it's nearly impossible to do it under the water. The second thing, the blocks under the water is extremely huge. And we cannot do the RTI under the water because we are limited with the camera frame. But virtually, by doing it through the 3D, so we create a high resolution photogrammetric model to any element. In a 3D world, we have an unlimited things we can do. Like 10-meter statue, we can resize it to 1 meter. And we can adjust the camera frame as we want. So in a virtual reality, on virtual world, we have a limited possibility we can do. Like you can do anything you can do in virtually. But in reality, we have some issue about it. So like I mentioned. So we a couple of years ago, we start to think about apply this technology since we have a very high resolution photogrammetric model to some blocks under the water. And we do two experiments, one with a block or a statue base, we know that there are an inscription on it, and another one that was so hard for anyone to notice even there are any inscription on it. So we gave it a shot to see. Photogrammetric model didn't show us any indication for the one I cannot read any inscription on, but it's show a very promising result to this one, which already we know there are an inscription on it. So anyway, this is the first block. This one we choose as a case study, which already we know that there are an inscription on it, but this is how it looks like under the water. As you can see, it's very hard to read what is inside it, but we know already there are inscription. And the second one is a marble statue base. As you can see in the left image, this is before it's got eroded or, affected with the condition under the water. And this is after we clean up the statue base. So it's from marble, and we have no idea if there are any inscription on this one or not. Literally, there are no one know about it. Dr. Jean-Yves Ambrier, he was the only one who said it's high possibility there are an inscription on this one. So here is a very short video to show you about the concept of how we do the virtual RTI on virtually, like virtually. This is a photogrammetric model to the obelisk base. It's not under the water, but this video will show you the concept of doing it virtually. So here is the camera, simulation of the camera, and this is a light put, and this is the ceramic bowl to capture the reflection. The light is indicated to the flashlight. Exactly, I do simulation like I do it that as a physical on the site as a normal RTI. And I will move the video. As you can see, once you move the light, I start to see some inscription on it. So here is the questions. And always came, and this is proof about mixed technology between photogrammetry and reflection transformation imaging is known as, or use this mixed technology, make us know the technology is not only about documentation, but also we can make a new discovery through it. So I will not go for this statue. I will go to the other underwater example. This image, as I told you before, we took two examples. The first one, we know there are inscription, and the second one, we have no idea if there are any inscription on it. And this is how the RTI work on the site. We make exactly a hemisphere dome of light, as you can see. We put the two ceramic bowl, as you can see these two bowls here, and we put a very professional camera capture it. And by specific code, just I press one code, just I press one button. The whole thing done totally automation. So the camera capture one photo, light number one will be open, and the ceramic bowl will capture the highlight. And once it's done, the camera will take another photo, and automation, the light number two will be on, and light number one will be off. And it's keep going to capture the whole 70 image. Each image will be in a different light direction. And after that, I will show you here on this video what exactly the result we achieved. After I got all the 70 image, I make a composition on the software, and I will show you the result. Before that, in this video is showing to you, in this video, I will show you the example which we didn't know there are any inscription on this marble base. So after we make a photogrammetric model to this base, we apply the RTI and we put it on the RTI builder here. And this is how it looks like inside the software. As you can see here, I just take this one here. As you can see here, this is how it looks like under the water. Definitely no one see any inscription on it. But as you can see here, inside the RTI, I have a possibility to remove the picture and add some filter on it. And as you can see, after I do that, I cannot see anything. I only see the eroded and all the details. But I will show you after I move the light. So as you can see here, because this is a 70 image and each image has a different light direction, I start to see some inscription on it. As you can see, I don't have to read the whole thing. It's because it's impossible. It's already eroded. But the most important thing, this is a proof that by using mixed technology, we can discover things we cannot see by our eyes. So it's not only about documentation or complete documentation from manual to digital, but also we can do some more discoveries. As you can see here, some letters we can read, the M letter, the X letter here. From each line, we can see some letters, and I can move the I can keep move the lights. So this is how RTI work. So this is how the result for this one, which we already didn't know there are an inscription, but by use mixed technology, we know that there are an inscription on it. And this is a second example here, which we already know that there are a Latin inscription on it. And it's already recorded and made as epigraphy in the 19th by the French mission. So this is how it looks like under the water. But after we make the RTI, mix it with photogrammetry, we did the same processor, and you can see, voila, we can see the whole inscription. So this is before, and this is after. So whole fully inscription showing. It's not only that, but I have a full control with the light in 180 degrees. So I can move the light, as you can see here from this image, and I can read more. By the way, this statue base belong in human tall, in the human body tall. So it's a very tall inscription. So I cannot under the water to put a light and just move the light under the water. So, or do even RTI under the water. So this is an incredible mixed technique between the RTI and photogrammetry with the fully automated code again. I just press one button and everything done automatically. So this image in the 19th, actually, French mission intend to make some sort of casting for the block or some blocks under the water to be able to know what kind of an inscription. So the middle image, this is how it's done in the 19th. And do casting under the water is really money consuming and time consuming. And this is what's the result. It's extremely nice in the 19th, but as I told you before, this is a money consuming and time consuming, but photogrammetry is never been like that. It's just like photograph under the water, professional, of course, in a professional way, and do all the process on your computer, and you don't have to pay more extra money or care about time because all the result you will got on your computer. And especially on the underwater side, we are usually not dive every day, or the mission not dive every day, just like 1 month in a year. No. Another thing very interesting is about how we can use VR, virtual reality, as a tool on under the site. As I told you before, it's 2 ways to do it: from video, like a 3D video, like I showed to you before, or to do it through virtual reality. So to do it through virtual reality, there are some challenge on it because we have to do some sort of data optimization to convert the photogrammetric model to game asset to be adapted in a VR. So this is how it looks like in the results. The great thing about virtual reality, again, it's you can create your own environment. So this is not the real environment under the site, but this is my own creation of my own imagination environment. I speak about the lighting and the visibility, but the 3D model is a photogrammetric model. So it's the real site. So basically, it's the real site. Of course, I can add fish, I can add music, so this is, by the way, this is in a VR. So if you just like, if you wear your VR headset, you can just like see the whole site and visit the site without even travel to Alexandria or without even dive. So this is a great tool for even non-diver people. People cannot dive, people old, people have issues diving, so they still can get great experience in VR. So this is a quick video. I will end the presentation about very basic publication we did since 2016 about the site with the Center de Alexandrie, and we still ongoing do publication on the site. Our first publication was in Dossier de Archaeologie. I'm very bad in reading French, but this was the first publication we did. It was in 2016, and after that we start to give a presentation in different countries, in Europe, in Greece, in France, in Italy, and so on. In Cyprus, of course. In 2018, I traveled to America, to United States, to give a lecture with the American Research Center in Egypt. To give a presentation about the underwater site, of course. It was an annual meeting, and also in 2019, also in America, I gave a poster and another paper about the underwater site, which was so interesting for everyone. Also, we published in Cyprus in 2019. Also, we published an article. It's called Underwater Photogrammetric Digital Surface Model of the submerged site of ancient lighthouse near Qaitbey. In 2021, we published our first article in Arabic, which we got a huge amount of feedback about, especially in Arabic. Like I mentioned before, most of the Arab countries in Middle East or in North Africa, they not fluent in English, and anything, literally like a lot of things related to photogrammetry and technology and archaeology, it's only in English and other language, but very limited to find an article in Arabic. And I think this is the first article only related to photogrammetry in underwater and archaeology in Arabic, and we got a lot of feedback every day, like people from all around Middle East and Mediterranean Arab countries read this article. Our recent publication, it was in 2023, like a couple of months ago. It was about the contribution of photogrammetry and computer graphic to the study and preservation of monument in Alexandria, Egypt. And this is published as a one fully chapter in the book. It's already now, we already published it. And last July, we were in Italy, gave another lecture also about the RTI, the virtual RTI, and about the underwater side, which we expect to publish very soon this year. And also, I think maybe next year, the Centre de Alexandrie will publish one volume about the underwater side, which will contain all information, all the workflow, everything we start since the 19th, since the mission in the 19th till now, from the manual to the technology. So it will be a big volume, will be published, I hope, next year. So yes, so this is all about the lecture. I hope this is a good lecture for end of the year, and thank you very much.
Yes, thank you. That was really, really nice.
Oh, thank you very much, Maurice.
Really astonishing results. And yeah, as
I just yeah, I would like to end of course this lecture by thanks a lot Honor Frost Foundation for the fund this big project for the Centre de Alexandrie, because even without Centre de Alexandrie, I will not be able to reach all of this result. So we all like a chain, you know, it's a circle, we all connected together. So this is something I really appreciated from the Centre de Alexandrie to keep work on this project, and of course Honor Frost Foundation to keep funded and sponsor this one of its kind project. You know, it's ancient forest lighthouse. No one sees the site in one piece. No one visited, like not no one visited, but few people just visited. You can do it in VR, you can do it in video, so you can revisit it, but through computer. So thanks for them. So.
Really great, really great. And as I said before in the talk beforehand, I really like your initiative of publishing in Arabic as well. So I think that's really a huge outreach to your region. So great work.
Oh, thank you, Maurice. Thank you very much.
Yeah, I guess we will now first give the word to Ziad to give you some of his advice and input, and afterwards we will of course open the floor to other questions. But please first, Ziad, thank you for being here, for joining us. And
my pleasure. Thank you, Maurice, for the invitation, and of course thanks to my dear friend and colleague Mohamed Abdelaziz for
Habibi.
This brilliant as always. So I would like to first to introduce myself. So my name is Ziad Morsi. I'm a maritime archaeologist, and I'm a lecturer of maritime archaeology in Alexandria University, and also the Honor Frost Foundation liaison officer in Egypt. So this actually presentation means a lot to me as a maritime archaeologist and as part of the Honor Frost Foundation as well. And on top of that, Mohamed was the one who taught me how to do photogrammetry back in 2012. So we started, or 2013, I think.
Yes.
12, 13, something like that.
Something
so we started, because Mohamed started teaching himself about the techniques totally by himself. And then he was very generous with us with his time and effort, and gave to a number of archaeologists in Alexandria the method and the know-how. And also we developed our own method, but all the bases, all the foundation was starting like almost 11 years ago or 10 years ago as part of this project. So first, actually, this project is really close to the foundation because Honor was one of the earliest archaeologists who started actually recording the site itself in the 60s. So with the help of Kamel Abu Saadat, who was the pioneer who discovered the site in the 60s, he asked the UNESCO for help in recording all this massive site, as you saw. And the UNESCO invited Honor to lead a mission in 68 under the water in Egypt, in Alexandria, to record the first few blocks. They couldn't manage actually to record a lot. As Mohamed was saying, the weather is not optimum in Alexandria. The visibility is very bad. Like normal visibility on the site, because I've been diving there, is 50 centimeters in like, that's the good and optimum weather. So back in the 60s also, they couldn't do it. But then later on, when the CEAlex started working in the 90s, they started recording manually. And as you saw, using the manual recording, you always misinterpret some stuff, and also you miss seeing stuff. And this is really crucial because as underwater archaeologists, one of the downsides of being underwater is the time limit, because we are only limited with the amount of air that is available for us. We are only allowed underwater for certain time per day, and also for certain time in the year. So eventually, trying to record everything and study everything as it is underwater is very time consuming. But then what Mohamed and the team in the CEAlex were doing is not just recording the site as it is, but also adding more layers of information on this recording. So it's a kind of a holistic project, as I would like to say. It's recording, documentation, preservation, and also interpretation and outreach, which is like all the models, the beautiful models that Mohamed has been doing. So it's a kind of a huge project, and I still it still have more, like 20% of the site is not covered. Plus, also there are more material that are under the concrete blocks which was put in the site for protection of the citadel in the 90s. So again, the site is still huge, and there are more and more that we can learn from the site. And I think using the new technology will give us like the opportunity to study the site from our houses, basically, as Mohamed is doing right now. Mohamed is in the States, so he can easily study the site while being there, while the team is actually digging under or recording underwater. Currently, they are actually these days working in their site. So it's amazing how the technology have evolved, and especially with what you were saying, Mohamed, about the rendering of the videos now with the new engine, Unreal Engine, and how fast things are going. So it's amazing. It's really an amazing project, and I think it's still there is still quite a lot of work to be done on the site, which is really it's really exciting for me, actually. So I have actually one question to Mohamed to start to kick off the questions. Have you used the RTI on the actual the statue of Isis? Have you used the virtual RTI of the to read if there are any inscription on the back mount of the statue or not?
No, actually, we didn't do that, but we can, of course, we can. It's
Yeah,
like I
because
said, it's
it's interesting.
yeah, it's very interesting to apply this technology for the statue. As I said before, the code actually for the virtual RTI is totally automation. The code
Mm.
from start to finish take between 1 minute and 5 minutes to get the whole result from start to the end. Of course, photogrammetric model take a bit some time to process, but since we had now a new development of application and computers now, it's just take like 1 hour from the beginning to the end. So yeah, we can do, of course, experiment about it, but
because
I didn't, to be honest. Yeah.
Because it might be interesting because we might actually find out whose this queen is, because there are still speculation around whose exactly this statue belongs to. And maybe also work on the other statue, the twin statue, which is the Ptolemaic king, which now stands in front of the Bibliotheca Alexandrina, and maybe try to, again, see if there are any inscriptions there, because there has been a lot of debate about who are those two, king and queen, are, and some people say it's Ptolemy II, some people say it's Ptolemy VIII. So there are this kind of debate, and if you can find out an inscription, that will put, like, that will prove without any doubt that these statues belong to these kings. So
yes, I think
maybe we need to think about that.
This will be very exciting. That's why I'm going, like I told you before, I'm going to publish this code I created and all the workflow from start to finish, because I don't want to be the only one who knows this kind of code. And now most of the people now know about photogrammetry, so it will be very exciting to let others actually use it for their research purpose. Like I said, like technology now, it's not only about documentation, like everyone, like we always known, but now we can make new discoveries, which is something so interesting by combining technology. So I hope I can do it very, very soon, to just let all others archaeologists do it. Maybe I will do it with bar publication next month. I can think about it. So since it's very close, so why not?
That's brilliant.
So sooner is better, so I can think about it. So
great. Thank you so much for your input. And I think you really showed how important the work is. So we got several questions. I think we should start with the raised hand of Mena. So please go for it.
First of all, thank you for this great lecture and information. And my question is, do you use a specific application or software for the VR, or you use Unity or something like that?
Oh yes, I use for VR. Actually, I go to the easy way, because since it's I didn't do that for advanced purpose. I use an application linked to Unreal Engine. It's called the Twin Motion. So this is also a full free application. All what you are doing is to do some data optimization for your high resolution photogrammetric model, and take the model, through it in the application, and connect it to VR, and that's it. Inside this application, there are a variety of options. You can do your own environment, like you saw in the video before, like you see. In the video I created, I make a simulation to the underwater side, not the video, 1 minute video I created, but the VR thing. I make a simulation in it was a real-time simulation. Just I did it in few seconds to create the whole virtual. Yeah, it's very interesting. The video in VR, the one I created in 2015, I didn't use a game engine. I used a software called 3D Max. For the 1 minute video I created after many years with better thing, I use Unreal Engine. You also can use Unity. Both are game engine softwares to use.
Thank you.
Those are more advanced than twin motion. Twin motion is just like, you know, very basic things. But it can be good for the purpose. Like if you would like to go to a conference, show people what you are doing, you can just do that very quickly. You don't have to do application, you know, and very advanced tool or these kind of things. You need only to get the experiment, you know, the experience, underwater experience. You need to get the feeling, how it looks like. So we don't have to be very complicated. And now technology keep development, so we don't have to make complication for ourselves.
So, and for photogrammetry, do you use a specific software?
Yes, for photogrammetry, I use a software called EGSoft Metashape. There are a variety of other software, definitely, but Metashape, very, very, very interesting software because there are a lot of tools we can fully control with the accuracy of our final product. Because as I said, photogrammetry for the underwater site, we do it for a research purpose. As I said at the beginning of my presentation, we didn't do videogrammetry. We didn't capture with fish eye for a reason, actually. In 2013 and 2014, we had a huge amount of experiment by use both. And that's why we decided to use a full frame camera, 24 millimeter camera frame lens, and capture in RAW format. So that's why we took this decision. EGSoft Metashape, like I said before, it's not about through images and press some buttons, but there are a variety of a lot of options. If you know quite well the software, you will get your desired result as a researcher. So,
Thank you.
sure. Thank you, Minna.
Okay, so we got a few more questions in the chat. Sorry, the first one is from Pavel. He asked, "With which software did you use for the post-processing?" I think that was around the.
Yes, I know this question. So the post-processing for the images, I use very basics like the Lightroom. Adobe Lightroom has a great feature about auto-synchronize. It's better always to use, of course, the color chart, you know, to make the color correction for it. Lightroom is very basic software we use for it. Just it's automation. Like as I mentioned before, each day we capture more than 2,000 images, and it will be very difficult to do it image by image. So automation is good. Perfect.
Yeah, I can imagine. Thank you.
That's why, again, we capture it in RAW format. RAW is so crucial format for your desired image for post-processing. If you use post-processing for JPG images, you will not get the same result as a RAW image format.
Just as you mentioned, RAW, after that, the RAW you converted into JPEG or TIFFs?
Yes, we use the JPEG. We made also a lot of experiment about kind of format, which might give us a better result. PNG, TIFF, EXR, so JPG, all we got the same result. We have to make sure when we convert from RAW to JPEG, not from JPEG to JPEG. Like after I make post-processing and export it as a JPEG, it's very, very important to not redo the post-processing on the JPEG because this leads to a change of pixel direction for the JPEG file save. And this will lead us to a lot of noise on the shape of the 3D model. So we spent like more than a year to do a lot of experiment about all of this stuff. So this answer your question.
Really helpful. Thank you.
Thank you. Sure.
The next question is from Ulaskan. I hope I pronounced it correctly. Did you take photos first with the camera from the field and process them in photogrammetry and adjust the light of the processed photos with V-RTI?
Yes. Okay. So first of all, I'm not the one who diving under the water. or takes a photograph. I'm the one who behind the scene computer graphics. So as the one who takes a photograph, Dr. Mohamed Said, again, I mentioned this again, but it's important to say it again. And after he takes a photo, photogrammetric photo, I do the post-processing, do the 3D photogrammetric model. After that, I have to make sure this photogrammetric model in the highest quality as much as possible. The triangle, the count of the triangulation is infinity. Like I tell the software, it's infinity number. Give me the infinity, the maximum you can give to me. And after that, I take this 3D model inside a third-party application and use the code. The code gave me an image, and I take this 70 image, each image in a different light direction, and I put it inside another application called RTI Builder. It's also for free. And that's it. So this is how I got the final RTI. The exported file is not an image, but exported file is a file called .rti, definitely. And to open this file, you have to download another application called RTI Viewer from also the same website, which called Cultural Heritage Imaging.com. So yes, this is answer your question.
Hope so. Okay, are there more questions? Then now is the time to either raise your hand or write it in the chat. Because I have a question. I don't know if you're the one to ask this question to, but since as you explained, you're always the guy behind the scenes more or less. But I'm always interested in how to get the points down on the sea ground. So how does your buoy exactly work? Because I've seen like a few variations of how they do this with the sea and everything. So if you
I know basics. Yeah, it's of course I will not the one who gave you like deep details, but we had also a lot of meeting and discussion about how we got the most accurate ground control point under the water, especially most of the days the stability is not the perfect way. So usually we also did a lot of experiments. So we put the point under the water, of course, and we put the buoy and the mirror on the top of the buoy and the rope. When we just fold the rope, the archaeologists put a lot of lead, to make sure it's so stable and so accurate. So the archaeologist outside, when he takes the coordinate system, he didn't take only one point. He take 100 of points for the same area. And we make sure when we take this point, we make sure it's on the most stable day. The sea is very calm. So, like I said, the great thing about doing photogrammetry, I don't have to take the point before take the photograph. But it's very important to put the point and the point appear in the photograph. And after that, we can take the coordinate point anytime later, even if after a year, 2 years, 3 years. But it's very important, crucial, this point is shown in the photo itself.
Yeah. Okay, great. Because I just think it's so fascinating how like so many teams face this like obstacle and all come to like roughly the same conclusion, but it always is like a bit specialized.
Yes.
So I think it's really interesting. Okay, we got another question by Sarah. Do you need to take the photo twice or multiple times? You showed us one picture, the blocks are available, and after a couple of years, they are buried under sand, are visible. Yeah.
Yes.
And after a couple of years.
As I mentioned on the first lecture, when we take the photograph for each season or for each year, we have to make sure there are an overlapping area between one season to another to make sure when we make the georeference of the 3D model, we have to make sure it's perfect enough. Like I cannot say 100% perfect because this is very difficult to achieve under the water. So we discover this sand level totally like by coincidence when we put the 3D model in 2 years in the same location, and we find that there are some blocks are not showing up. 2014 there are blocks, in 2016 in the same area there are no blocks. So that's why we make the deviation analysis to know what exactly going on. It's very obvious that the sand level go up, but it's very interesting to know in these 2 years how high the sand go up. That's why we make deviation analysis by put the two models in the same coordinate system and measure the gap between. So this is how it's done.
Yeah. Great, thank you. So, more questions?
People interesting, that's good.
Yeah, I would say that if you are interested in getting the link of tonight's session, just write us an email, please, so then we can forward you a link with it. I think that would be the best for now, and then we can discuss within the team how we will proceed with the recordings. Okay? Because
Yeah, I wish, Maurice, you can publish it online. It's
Yeah.
will help a huge amount of people.
Yeah,
Believe me,
of
it's
course.
just it's very interesting.
Yeah.
Just think about it. I'm just like
Yeah,
pushing the
yeah.
of course.
Yeah, we will see how we will proceed with this one, because this is actually the first we recorded.
Okay.
Because we are of course always a bit cautious with new material published.
Okay.
So, but yeah, we will see how next year maybe
Okay.
might change some things. Who knows? Okay, there is another question by Mustafa. When using a software mushroom, we will get the same results. Okay, not more of a statement than a question, actually.
Yes, Mustafa, it's like I mentioned, it's not about the software. I said I use when I got asked what software I use Agisoft Metashape, because as archaeologists, it gives that plenty of option to control with our final result as a researcher and archaeologist. Mushroom software is totally free software. You have no idea what is going on in the algorithm. You just through the image and leave the software do the job. You know, you have no idea what is behind it. When you do your own publication, after that, you have no idea what is going on. You just show in your publication the 3D model. But if someone expert and would like to investigate about what behind the 3D model, I have no idea. I will see where is the noise, where is the distortion, what is the accuracy, and this kind of stuff. So mushroom, and it's totally free. You have no idea what is going on inside it, but the result still may be more or less the same. Like right now with the new technology, you can create your own photogrammetry with your iPhone. And it's very interesting because you don't have to take photograph and wait for the process, but you can just do everything real time in your phone. But again, we back to the point zero. I have no idea what is going on in my iPhone. What is the quality? What is the report to give it? And Agisoft is very easy to use, very easy to have all of these kind of controls. The report is so interesting. So this is just my comment about mushroom, because a lot of people got conflict about any other softwares, and I have to say why we choose this software to work on, which I believe most of archaeologists use the same software.
Yeah. Well, I think that was a really worthy last lecture of the year. Thank you so much for
Merci
letting us
beaucoup,
in your work. No, that was really great, and I think we all enjoyed it very much.
Thank you.
So thanks a lot. And also thanks to all the people who participated again. It's really great that every month so many people decide to join our Mara Monday lectures. And yeah, I mean we often get get praised for this project, but it's in the end it's all down to the people who decide to join, you know. So we're really happy that we can do this and that we have so many engaged listeners every month. And yeah, we hope that you enjoyed this year's Mara lectures, and that you enjoyed the new newsletter that we implemented this year. I think it's a lot of fun for us to to always gather all the knowledge that we can find present it to you, and we hope it's helpful. And yeah, so we will see you the next time, not so long in the future, because at the 8th of January we will have our first Mara lecture of 2024 with Carmen Ramirez Cañas, speaking about Phoenician Punic coastal sanctuaries in the Western Mediterranean. And yeah, we hope that we will see you all next year in good health. And I know it's of course quite far away, but let me all wish you nice festive season and a good end to this year. And yeah, we're very much looking forward to see you all again next year. Take care.
Thank you so much, Maurice, and Merry Christmas and have a great December. So can I ask you to send me also this recorded lecture?
Yes, of course.
Yes, thank you so much. So you already know my emails.
Yeah.